Chapter 6, Section 6. In this section, we are going to learn how to solve log equations and how to solve exponential equations and solve log and exponential equation using a graphing. So let's look at solve logarithmic equations. The property we're going to use is if given the log expression, we can write into equivalent exponential. All right, and another theorem we can use, if the two log as the same base are equal, okay, log a as base of m equals log a as base of n, that indicate m must equals n. Okay, and m and a, they're all positive numbers, and a is not equals 1. So now let's look at the example. Okay. So in this equation, left-hand side is a log, right-hand side is a log, and then they both have the same base, 5. Okay, so we can use the property log a as base of n equals log a as base n, and then we can derive m must equals n, right? All right, so now all we need to do is the factor, okay, need to go on the top as exponents. Okay, so we rewrite as log 5 as the base x squared equals log 5 as the base of 9. Okay, so in this case, this is the m, this is the n. Okay, so now we can let x squared equals 9 and then convert solving a log equation into solving a quadratic equation, and then use square root method, right? X equals plus minus 3. So we got a two solution, x equal to 3, x equal to negative 3. Okay, and then we just have to check, will that match the domain of the log function? So we have 2 times log 5 as base x. So here we require x must be greater than 0, right? Must be a non-negative number. That's why x equals negative 3. This solution must be discarded. Okay, so the only solution is x equals 3 for this log equation. All right, so this is the detailed solution, and then do the check. That's why x equals positive 3. That's the only solution for this equation. All right, and then let's try another one. Left-hand side of equation is the 2 log with the same base 5, right? Right-hand side is a constant. So adding the 2 log, we can combine these two into a single log, right? The sum of 2 log actually is the log of the product, right? So log 5 as the base, x plus 6 times x plus 2. That's equivalent to, break it 2 logs and add them together. All right, so now we just have to simplify this. So that's log 5 as the base. 2 binomial multiply, we got a trinomial, right? X squared, okay, that's first term. Inner term, outer term, they are like terms, 6x plus 2x, right? 6x plus 2x, we got 8x, and the last term, 6 times 2 plus 12 equal to 1. And then we can convert this to an exponential, right? That's 5 to the first power equals x squared plus 8x plus 12. And then subtract 5. 5 to first power is still 5, right? So subtract 5 on both sides, and then we got a standard quadratic equation. X squared plus 8x plus 7 equals 0. And then we can write as a factor form. We can easily say, tell 7 we can break as 1 times 7, right? And 1 plus 7 equals 8. So we can factor as x plus 1 times x plus 7 equal to 0. And then apply 0 factor rule. So either x plus 1 equal to 0 or x plus 7 equal to 0, right? And then solve each linear equation. we got x equals -1 or x equals -7. So are those both solutions? Let's see the domain of x. Okay, for the first log, okay, x plus 6 is the output, right? So we have to make sure x plus 6 greater than 0. And similarly, x plus 2 need to greater than 0. So that's derived x must greater than -6. From here domain, we figured x must greater than -2. Okay, combine this. X greater than -6, x greater than -2. So combine the two, x must greater than -2. X greater than -2 also satisfy x greater than -6, right? So let's see, we got this two solution. Which one is greater than -2? Only x equals -1 greater than -2, right? That's the domain. So we have to discard x equals -7. That is not satisfying the domain. So the only solution for this equation is x equals -1. Okay, only one solution, which is x equals -1. Okay, you can look at a solution from book. So x equals -7, that's actualness. We have discarded, and then only one solution, -1.